All right, let's talk about conservation of energy. So I have a PowerPoint, and we're going to go through this. And there's a video embedded, and let's hope that that works. This is Mr. Gregg, by the way, for those of you that don't have me in class. Hope everybody's doing good and staying safe and getting outside a little bit and making making lemonade out of all these lemons that we got here. All right. Okay, so conservation of energy. So we're going to use the example of a roller coaster on this, and I've got something to do first. But does anybody know what roller coaster this is and where it is? Maybe you've ridden it. I'll let you think about that. Okay, so let's see if this works here. But I've got a kind of a warm up question for us before we get into determining or observing conservation of energy, I guess, in a roller coaster.
Hi, so today we're going to talk about conservation of energy. And to understand that, we're going to use an example of a roller coaster. Before I do that, though, I just want to show you this short example to kind of show you how this works. So here's a box for box jumps. I'm about 80 kilograms. This box is 30 inches. I already did the math. That's 0.76 meters. So up on the box, we can think about what my potential energy is, which is 80 kilograms, my mass, times gravity, which is 9.8 meters per second squared, times the height, 0.76 meters. Then I jump. And using that initial information, we can determine what my velocity is when I hit the ground, which we'll do.
Okay, my shirt even says determined if you saw that, so that works out pretty good. All right. Okay, so just to review, so there is the box jumping box, 0.76 meters. I'm on the top of it. That's me at the Circleville Pumpkin Show eating a pumpkin burger. If you don't know anything about that, sorry. If you do know about it, you know about it. Earth, of course, has a gravity of 9.8 meters per second squared. So this is the information that we need to determine potential energy. So mass times gravity times height, put all that together, and my potential energy is 595.8 joules. All right, again, just multiply all that information together. So once we know that, and we also know that mechanical energy is potential energy plus kinetic energy. So kinetic energy, when I'm on the top of the box, is 0 because I'm not moving. So that means that mechanical energy is going to be the same as my potential energy, 595.8 joules. Now, at the bottom of the jump, now again, remember, mechanical energy is potential plus kinetic energy. My potential energy is now 0 because I have no height. And if we think about mass times gravity times height, if any one of those are 0, then that's going to make everything 0. So kinetic energy at the bottom of the jump is 595.8 joules. Now we can go even further and we can calculate the velocity that I was traveling at towards the ground at the bottom of the jump. So we can use the equation, which you should be familiar with by now. Kinetic energy equals 1/2 times mass times velocity squared. We plug the information in that you already know. We know my mass. We know what the kinetic energy is. We kind of work that a little bit to 595.8 equals 40 times v squared. 1/2 times 80 is 40. We're going to divide both sides by 40 to get velocity squared by itself, because remember, when we solve equations algebraically, the goal is to isolate variables. 14.9 equals v squared. We're going to take the square root of both sides, and that's key. And if you're using your iPhone on that, see. Let me show you. Just as an okay. Well, actually, let's see here. So, okay, so, okay, 14.9. And then the button that you want is, where is it? Okay, it's right. Ooh, shoot. Now I'm having a hard time. It's right here. It's that. You see the square root button there. And I'm going to round that to 3.9. So 3.9 meters per second towards the ground. Okay. But again, you got to flip your iPhone sideways to get that option to do the square root. Okay. So that's a warm-up question. Okay. That's just a system of mechanical energy where we're just going up to down. Okay. So now we can think about a roller coaster, which is a little bit more complex. Okay. Now there's kind of two parts to this. The first part is just figuring out the potential and kinetic energy. And mechanical energy. Okay. And then we can take this a step further. And in some of these examples, we can determine velocities and we can determine heights and things like that for unknowns. Okay. So I would say that, as far as your level of understanding goes, if you can, step one, understand the relationship between potential and kinetic energy as it relates to mechanical energy for each of these four steps. And then step two is to take it a step further and be able to solve for velocity when you don't know it, or solve for height when you don't know it. And I'll include all that in this example. But just to kind of get you, just kind of give you, a couple baselines of understanding. Okay. So there's four positions. There's the top of the hill, okay, which as you can see is 4 meters. Okay, we have a cart that has a mass of 50 kilograms. The second position is at the top of the loop, and the height there is 3 meters. The third position is as you come out of the loop, where your height is 0 meters. Okay, so the cart is essentially on the ground at that point. And then the fourth position, where we don't know the height, but we do the velocity, is 6 meters per second. Okay. Now, you may be thinking about friction a little bit. I'll get to that at the end. Okay. So, but for right now, we're just going to assume no friction, and we'll go from here. Okay. So, I'll have a picture of the roller coaster in the upper right that you'll be able to see the whole time. So, we want to first determine the potential energy at position 1, and you can see in the title of the slide, position 1. So that's 50 kilograms times gravity times height, and that's going to give us 1,960 joules. Now, remember, so if that's our potential energy, and remember that mechanical energy is potential plus kinetic energy, and kinetic energy at the beginning is 0 because the roller coaster isn't moving at the beginning, then our mechanical energy is going to be 1,960 joules. Now, once you know that, and this is key, once you know that, then you know that you have mechanical energy at position 1, 2, 3, and 4. It's all going to be the same. Mechanical energy, once we establish it, is not going to change. So again, we know that position 1, 2, 3, 4 mechanical energy is 1,960 joules. Okay, now we can move to position 2. So first we want to just calculate potential energy because we have a different height this time. So we use the same equation, mass times gravity times height. That's going to give us a potential energy of, oops, got ahead of myself a little bit there. That would give us a potential energy of 1,470 joules. Knowing that mechanical energy is 1,960, because again, it's the same for all positions, we can determine the kinetic energy. Okay, and kinetic energy is going to be 490 joules. All right. Now, remember earlier I talked about baselines. Are you trying to just be able to determine potential and mechanical energy and kinetic energy for each of these positions, or do you want to take it a step further and know velocity? Okay, so if you're not going to take it a step further, then you can skip the next slide. But since you're watching a video right now, I guess you're going to have to watch, but I'll show you now how to calculate for velocity. Okay, so we're just going to use kinetic energy equation, 1/2 mass times velocity squared. Plug in the numbers that you need. And there's an example of this on slides 7 and 8 if you want to go back and take a look at those. We're going to take the square root of both sides after we divide both sides by 25. And that's going to give you a kinetic energy of 4.4 meters per second through the loop, I guess is how we'll say that. So that's position 2. Okay, for position 3. Okay, so we know that potential energy is 0 because there's no height. And we know that mechanical energy is potential plus kinetic energy. So we also already knew that mechanical energy was 1,960 joules. So that's what kinetic energy is going to be there. All right. Now, again, if all you're trying to do is determine potential and kinetic energy for each position, assuming that we know mechanical energy, then you're good. But if you wanted to go ahead and determine velocity as well, then you would create this equation. So 1/2 times 50, remember, is 25. So we'll divide both sides by 25. That's going to give us 78.4 joules. So we'll then take the square root of both sides, and that will give us a velocity of 8.9 meters per second towards the finish. Okay, and last but not least, at position 4, so we don't know height, but we do know velocity. So we can, if we know velocity, then we can solve for kinetic energy. So kinetic energy, 1/2 times 50 times 6 squared, because the velocity is 6. So 1/2 times 50 is 25. 6 squared is 36. And so that's going to give us a kinetic energy of 900 joules. If mechanical energy is potential plus kinetic energy, then 1960 equals potential plus 900. So then we just subtract, and that's going to give you a potential energy of 1,060 joules. Again, if all you're trying to do is determine potential and kinetic energy, you can stop here, but we can also determine height and answer that the question mark in the diagram using the potential energy equation. So there it is with the numbers plugged in. Again, we know the mass is 50 and we know gravity, and your height is going to be, once you determine all that, I think 50 times 9.8 is 490. So you'll divide both sides by that, and you'll end up with a height of 2.2 meters. So from this diagram, and really from not that much information, we knew the mass of the cart, we knew height at 3 different positions, because we also knew the height at position 3. We knew it was 0 because it's on the ground, and a new velocity at a 4th position. We were able to determine all the rest of that information about the roller coaster. So yeah. Now, I mentioned friction in the beginning. What about friction? And I have a really good answer for you for that. It's a very, very good answer. Okay, here it is. All right, take a look at this picture. These 3 people on the top, some of you may know that are watching this video, we are probably not the ones that are going to tell you anything at all about friction and how it relates to this roller coaster. But if that's interesting to you, these 2 individuals on the bottom teach classes in physics that you can take when you're a junior or a senior, and you can learn all you want to know about friction, and it will be fantastic. So there you go. All right. Yeah, that's what I got. So good luck. Reach out to anybody that you see an arrow pointing to in this picture if you have any questions. And again, I hope everybody's doing really well. And we will talk to you soon. Thank you.